All right, so we're good to go. So I want to talk about more aspects of homework 3 today, and I want to start looking at some code for implementing the stick picking game, and that's going to bring us talking about functions and modularization and writing pseudocode. So any questions before we get into all of that? All right, I'll take the silence as a no questions. We are good to go. Um, so hopefully everybody has done homework 2 at this point. I'll pull down repositories today or tomorrow, and I'll send you a note if there's a problem. If you haven't done homework 2 yet, go ahead and do it. Right, even though the deadline has passed, I need everybody to do that and get 100% on it. So send me an email on the Linux server with your GitLab ID, push your repository over, make me a reporter. All right, let's see. So let's talk about writing functions in Bash, because this is going to help us with breaking our code into pieces. So Bash is a scripting language, and we don't have function calls with arguments passed on the stack and sort of the formalism that we have in other high-level languages. But we can still implement pieces of our algorithm in separate parts of our script and have basically functions. So let's play with this. So let's make a function that, I don't know, function called user count. All right, so keyword is function, followed by the name of the function, followed by a curly bracket. Okay, and then the number sign is just a comment. So here's my function, which checks how many people are on the system. And so I'm going to say, C equals back quote, who pipe into word count lines. And then I'm just going to echo that. And then a closing curly bracket ends my function. All right, so if I run this, nothing appears to happen. I've defined a function inside here, but I haven't, in some sense, got a main program. This is just defining a function called user count, but that function doesn't execute unless I call it somewhere. So let me make something like a main program, right? So I can say echo hello, and there's my echo statement. So let's go ahead and call our function count. So our user count, let's just call user count. Okay, so just typing in that keyword will say find a function with that name, go ahead and execute it. So this is the first example of a function, is something that you just call it and it does something. Okay, and that can be useful for, you want to print the instructions for how to play your game. You can make a function to do that, and you could call this function in the beginning, and then if the user makes a mistake when they're answering a question, you can just call this function again, and you don't have to write those echo statements 2 or 3 spots in your program. It can just be a function. Okay, so that's one application of this. We can also pass information to a function. All right, so let's see, how could we do this? All right, we're going to make this function a little better. I'm just going to call this count. And this is going to either tell us how many people are on the system or how many processes are running. Okay, so I have a command ps-elf that I can use, which will show me every process on the system. And if I put that into word count-l, I'll see there's 186 processes running. All right, and if I say who, then that'll show me how many people are on the system. So let's modify this function. So if I call this function with a u, I want to look at how many people, how many users are on the system. That's the result of calling the who command. If I call it with a p, I want to return the number of processes. All right, so the way we pick up command line pick up arguments that are passed to a function is with $1, $2, and so on. So let me be a little wordy about this. Argument equals quote $1. This should be a p or a u. Arf. All right, so if the argument that you call this with is a u, then it should count the number of users using the who command. Else, if the argument that you pass is a p, then let's set our count equal to ps-elf. Put that into word count-l. Otherwise, let's just set our count equal to 0. And then let's just output what that count was. All right, and so I'm just going to call user count down here. But I changed the name to just good old count. Okay, so I'm just going to call the count function, and count is just 0. Let's call count with a u. Let's call count with a p. Let's call count with ha ha ha. All right, so when I called it with a u, it told me the number of users on the system, that's 14. When I called it with a p, it told me the number of processes on the system, that's 190. When I called it with ha ha, that was illegal, so it just gave me back a 0. All right, so this is just an example of a function. I've got all of this logic, and it's hidden inside this one thing called count. And so if the goal of my main program was to find the number of processes on the system, I could do something like this: p equals quote count the number of processes. And so I can call this function, I can pass an argument to it. Let me call this something better than p. Let me call it proc. So I can pass an argument to this function, which is p, and I can capture the return value from it, the thing that it's echoing, and save that in a variable, for example. So fun2, my variable prox equal to 183. So we can make a function, we can pass arguments to it by we can run the function by just typing its name, right, using that on a line of our script. We can pass arguments to it, however many arguments we want, by just listing them after the name of the function separated by spaces. And we pick those up in here by using $1, $2. We can use $number to see how many arguments have been passed and so on. And then anything that this script echoes, we can capture by invoking that function inside back quotes, which is what we were doing yesterday. All right, so we can pass arguments, we can get return values back. And it's a crude mechanism in some ways, but it's powerful enough to be able to do a lot of general processing with this. All right, so I'm not requiring you to use functions on homework 3, but I want to look at ways that we can approach homework 3, and I'm going to talk about this in the language of functions. And if this works for you, that's great. If you really don't want to use functions, that's okay. But something just to keep in mind, something to play with. Okay. And so I want to look at pseudocode now for our stick picking game. So we know the goal. Oh, let's see. Not sure if this was asked yesterday, but what's the second shebang? And so that's just my personal thing. The only time that a comment is anything other than a comment is the very first line, right? If that's a shebang, then this is the file you want to run the script through. This is just a comment, but I just kind of put it in there to separate the shebang part from the rest of the code. There's no reason for that. It's something I started doing a long time ago, and I still do it, but it has no function. All right, so let's take a look at homework 3. So I want to think about the algorithm that we're after. Okay. So what I'm going to be talking about this afternoon, right, or this morning, if you're already, consider yourself a very strong programmer, if you've been programming for a while, if you already have your own habits for writing code, right, don't worry about what I'm saying here, okay? I'm not going to ask you or suggest that you change the way you write code if you're already successful at writing code, okay? But if you're in the category where you don't think you're a very strong coder, you're not sure how to begin, sometimes you open the editor and you stare at the empty screen and 20 minutes passes, right, and you're still staring at it because you don't know how to start. I'm going to describe some ways to think about writing programs that can help you get through that sort of mental logjam in the beginning, and then start taking complex problems and breaking them down into more manageable pieces. So one way to do this is to think about algorithms, okay? Because, bash, we've got these funny bracket space and, $paren, and all of this business. And C, we've got, char star and malloc and argc, argv, and pointers and segfaults, and all of these details which have nothing to do with playing a stick-picking game. Right? Our first goal in writing something like stick is figuring out what are the steps that should be taken to play this game. We want to think about algorithms. Okay? This is a high-level view of our assignment. We're not going to think about bash code. We're not going to think about variable names. We're not going to think about getting out of loops if something exceptional happens. We're going to think high level. What are the steps that should be taken to play this game? And one way to view programs is with this trilogy of input, process, output. Okay, this is a really reductionist view of a program. Take something in, do something with it, put out an answer. And a lot of programs, this is exactly what you have, right? You want a program that solves quadratic equations. So you input the coefficients of your equation, you process it, negative b plus or minus the square root, etc., and then you output the answer, the two roots to your equation. Okay, input, process, output, input, process, output. And we can think of a lot of things like that, particularly if we allow this process step to have its own input, process, output. Okay, and if we have this process step something that can include loops. So this is just a very high level view of how we can think of a program. We can also think of this as some sort of initialization, some sort of main body, and then some sort of finishing up or deinitialization. So let's look at our stick picking game and think about it in these more high level terms. What do we do when we play the stick picking game? So we have some kind of introduction. So we say hello. We find the number of sticks to play with. And we find out who goes first. Okay, that's the initialization part of our game. It's also kind of the input part of this input, process, output grouping, right? We're saying hello, okay, there's some output going on there. But this is all sort of the startup stuff, right? The main goal here is to figure out how many sticks we're playing with and who's going first. Okay, we got to know those things before we can play the game. And then we're going to enter sort of the main body of our game. And there's two main things that are happening, right? The user turn and the player turn. So if it's the user's move, do the user move. If it's the CPU's turn, do CPU move. And go back up to the top. Alright, this is a super, super, super high level view of the game, right? Basically, we're taking turns. The user doesn't move, the CPU doesn't move. Now, if the CPU is going first, when we first come in here, we'll say, is it the user's move? No, it's the CPU's turn, so we're not going to do the user's move first. Is it the CPU's turn? Yes, it is, so we'll do the CPU move. Okay? But we can see here already we need some way of keeping track of whose turn it is. Right? Well, up here we're going to find out who's going first. We need to use that information down here somewhere, so we probably want some kind of variable that's going to tell us whose turn is it. Okay? I'm not going to put that in this level of code, but that's already in the back of my brain. We're going to need some kind of variable that says whose turn it is, and we're going to, you know, change that as the game plays. Okay? We also need a way to get out of this loop. So I'm just going to put a little note here. Which says every time that the user makes a move and every time the CPU makes a move, we need to check to see if the game is over. And if it is, we need to exit this loop. And once we exit, you know, we can say goodbye. And then we're done. Alright, so this is a high-level view of stick. There's a lot of detail hidden underneath this. For example, find the number of sticks to play with. Well, we have to ask the user, how many sticks do you want to play with? We have to get a number from them. We have to see if it's an integer. We have to see if it's at least 10. And if it's not, then we have to say, please specify an integer at least 10. And we have to go back and repeat all of that. Ask them for the number of sticks again. So that's going to have a loop. It's going to have some conditionals. It's going to have some logic. Okay? But I'm not worried about that yet. I know my goal at this point is just find out how many sticks to play with. Find out who goes first. Ask them to enter a U or a C. If it's not a U or a C, ask them again. Go back, get another input. Alright, if it's the user's move, so I'm going to have some variable which says, is it the user's turn to go? And if it is, then do the user move. Okay, what's the user move? Ask them how many sticks they want to take. Make sure they put in an integer between 1 and 4. If they don't, see if they've made a mistake in the previous entry, and if they have, exit the game. Otherwise, warn them that that's an illegal answer. They have one more chance. Ask them again how many sticks, and see if it's a legal integer between 1 and 4. And if it's not, exit the game. If it is, then take that number, subtract it from the pile of sticks, print out the new pile of sticks. Number of pipes with a parentheses after it containing the number. Okay, that's all of this. That's what I mean by do user move. CPU move means look at the number of sticks left, find what it is modulo 5. If it's equal to 0, take 1 stick, otherwise take the number of sticks mod 5 sticks. Subtract that from the number of sticks, print out the new pile of sticks, that many pipes, followed by the number of sticks in parentheses. But that's buried inside this do CPU move. Alright, the goal here is I want to look at high level flow. I want to look at what's going on at the top level and make sure this makes sense. In particular, this business of deciding whose turn it is, because if you say the computer should go first, I don't want to do this first step. Right? If I put this first step down here and the user says the computer should go first, that works fine, but if the user says the user should go first, you have to skip that first CPU turn. Right? That's some logic. That's using some variables and some conditionals, but I don't want to be thinking about that when this statement is 25 lines of bash code. Okay? I want to think about it logically at this point. So I would go ahead and I would add a variable that says whose turn is it, and put in some logic here and so on. Okay? So this is very much top-down development. And you generally develop code either top-down, right, starting with the high-level view and then working down to the more detailed, smaller pieces, or bottom-up, where you start by writing the very small, fine-grained units and start assembling them together. Okay? We do a combination of both. Right now I'm going top-down, but at some point I'll switch and I'll start working bottom-up. Alright, so someone says make the user's turn a runnable command, question mark. We can do that, right? So we could make a function for the user move and a function for the CPU move. We could write a separate bash script for processing the user move and the CPU move, right? And we can run bash scripts inside bash scripts by just typing their name. And we can capture the output of those scripts by executing them inside back quotes and assigning the return value to a variable. So the way you actually implement this can follow the structure of your pseudocode. For example, say hello, that could be a function called say hello, which might have, 10 echo statements printing out, welcome to my game, blah, blah, blah. Find the number of sticks to play with. We're going to code this up in a second, right? And so each of these can be a function. All right, so I recommend doing this before you ever get into the editor, right? Before you ever fire up VI, before you ever start actually writing bash code, think about the pseudocode. Think about the algorithm. What are the steps? All right, let's write some sample code. Let's just look at this piece where we're trying to find out who's going to go first. So I'm going to make a sample script here for doing that. I'm going to put a function in here to find out who goes first. Is that a question coming? No, I guess not. All right. Let's make this a function. All right, function who goes first. Alright, so we'll prompt the user who should go first, and we'll remind them type in a U for the user, a C for the computer. Let's read their response, and let's make sure it's a valid response. So if the response is equal to C, what do I want to do? I don't know. I want to go on with my life, right? If it's not equal to C, I want to see if it's equal to U. If it's not equal to U, then I want to tell them that they should put in a U or a C and do this all again, right? This is the point where a lot of times people who are writing code start feeling really frustrated and maybe a little anxious, and maybe like, I don't know what I'm doing. Why am I taking this course, right? This is intimidating. We're sitting inside here, we're trying to write bash code, maybe we're using VI, right? And we don't know what we're trying to get bash to do, so how can we write bash code for it? So forget about VI, forget about the editor, forget about bash. Let's write pseudocode. Alright, so who goes first? Well, you know, I want to prompt the user. I want to read their answer. And if it's not U and it's not C, I want to go back up here and ask them again. Right? That's sort of what we get from reading the prompt, the assignment prompt, right? Ask the user who's going to go first. If they don't enter a U or a C, ask them to enter a U or a C and try again. And do this forever. There's no limit to how many times the user can try to answer a U or a C. Okay? There's a 3-line pseudocode version of this function. And so I need some kind of loop. Right? I need a prompt, an echo statement, an input statement. I need some kind of logic that controls whether or not I should loop some more. All right, so how do we do looping in a language? We do a while statement, and there's a few ways to do this. Two sort of main ways is, one, to use an infinite loop with a break statement that gets us out of the infinite loop. So if we coded this as an infinite loop, we would prompt the user, we'd read the answer, and if they put in a legal answer, we would say break, get out of the loop. Otherwise, we'll go back and we'll do this again and again. The other way to do this is to make your while statement that says, while we still need to get an answer, right? So we could use a flag or something which says, do we have a legal answer? And while we don't have a legal answer, we're going to keep doing this. All right, so let's code this up with a infinite loop and a break. Okay, so So here's a classic infinite loop. Which really says do this forever, but in reality it's until we execute a break statement. So what are we going to do? We're going to ask who should go first. We're going to read response. Is this a valid response? If the response is equal to C, we'll break. Because we don't have to loop anymore, they put in a valid response. If the response is equal to P, we'll also break. Otherwise, we're going to go back to the beginning of our loop. All right, I'm indenting here. I'm indenting all of this because it's sitting inside a function. And eventually, you know, I'm going to end my function with a curly bracket. But visually, I can look at this and I can see all of this is inside the function. I'm indenting this because it's inside a loop. And it's helping me visually understand what's going on in my code without having to actually read the particular statements. Right? So do you indent comments or not? It depends. So most things that auto-indent for you will indent comments as well. I usually put comments on the left because I like to see what the comments are. Right? It helps me if they jump out. Personal style. Okay? But you want to be indenting your code. It will help you with writing it. It will help you with debugging it. Right? But the cleaner the job is when you're writing it, the less debugging you have to do. All right, so what does this say? Infinite loop. Ask who should go first, get a response. If it's a valid response, I'll kick out of the loop. Otherwise, I'll go back up to the top and ask again who should go first. Okay, once I kick out of the loop, let's just echo what the response was. All right, so my main program is going to start off with, you know, who goes first. Of course, I got syntax errors. These were my rules, so I got to stick by them. So my rule was you have to write if-then statements like that. I'm going to throw some vertical space in here also to make it more readable, at least for myself. Here's a block of code which is this a valid response? Here's another block of code related to that. Here's a block of code which is reading the input, right? So I'm trying to make it easier for myself to read this. So I can run turn one, who should go first? I can say haha, I can say me, I can say you, I can say user. I can say computer. Okay, computer will move first. So I messed up the user part of my logic. That should have been a user. Alright, who should go first? U for user. Who should go first? C for computer. Anything else? Ask again. Alright, so all of this is just finding out who goes first. Okay? That's this one line of pseudocode, find out who goes first. And it's not, you know, thousands of lines of code, but it's a loop, it's some checking, it's some if statements, and so on and so forth, right? I don't want to think about all that when I'm here. I just want to think who goes first, and then I'm going to jump into the body of my code, right? So we're separating things out into different functions, different modules. So this is what I keep calling modularization. Okay, breaking things into logical pieces. All right, so can we make this into, you know, a true function? So let's call who goes first as a function, and let's take the value that it returns and save that in this variable called first move. So my main program is going to start here. It's going to say, find out who goes first, take the result of all of that, put it in this variable called first move. And then let's echo the value of first move. All right, well, I turn 1, and I've got a problem because immediately I don't see anything. Right, so what's going on here? All right, first move is who should go first, who should go first, who should go first. First move will be C. Got weird stuff going on here. So what's going on is that when I run a function inside back quotes, right, everything that this function prints goes into basically the value of this piece of the statement, which means my variable first move is being set equal to all of the output produced by this function, including, you know, who should go first, and the first move will be, and so on and so forth. So let me show you a really quick way to deal with this, and we'll talk about this more when we talk about standard in, standard out, and standard error. But when we read, we can actually say read-p, which means prompt, and then we can list a prompt, and then we can say what variable we want to read. So instead of just saying read response, I'm going to say read-prompt, put in a string I want displayed, and then the variable I want to read. And the effect of this is the system will print out this message. As a bonus, it will not go down to a new line. It will sit here after the colon and wait for me to type in my response. And when I do that, I'll actually see my prompt on here, even though I'm capturing the output of that function and putting it into a variable. The prompt actually comes to a different output channel, which doesn't get captured. So who should go first? Me, you, user. Okay, and my variable was set equal to the string first move will be you. All right, well, we can clean this up really simply by just echoing the response. So who should go first? Someone, haha, okay, I'll say the computer. And first move is equal to C. So now I've got like a genuine function, right? This whole thing, I execute it by just saying who goes first inside back quotes, and I can assign the result of that to a variable, and that variable is guaranteed to be either a C or a U based on what answer the person put in. And if they typed in something other than a C or a U, all of this will just iterate and keep asking until they put in a legal response, and that'll be the value of this variable. So now I have one line of code, first move equals who goes first, that I can replace this line in my pseudocode with. Alright, someone asked about functions outside of the main program, and I'm not sure what that would mean. If you're asking about functions in a different script, I mean, this could be a totally different script called who goes first, and this would look exactly the same, and this would be exactly the same, but instead of saying function who goes first, it would just be a file called who goes first, and then I'd be running that. The nice thing about functions is, you know, it puts it all inside here. It's easy to see and modify. The nice thing about putting this in a separate script is it's general purpose. You can call it from different scripts, right, and use it in more than just this one main script. All right, so that's an example of modularizing, right? Putting this thing in a separate function. So this is using an infinite loop. There's other ways you can do this. Okay, so here's a perhaps more clear way of doing this. Who goes first? Well, first thing we're going to do is ask the user who goes first and get a response. And we're going to say well, the response is not C, and the response is not U. Do, let's ask him again. All right, this is a much shorter set of code. And it's a little cleaner feeling in some ways, right? Because what is it doing? It's doing kind of what we had right here. Prompt the user, read their answer. If the answer is not valid, go back and prompt the user again and read the answer again, right? And that's what we have here. We're going to prompt the user, we're going to read their answer, and if the answer is not valid, if it's not a C and it's also not a U, we're going to prompt them again and go back to the top. See if it's valid, and if it's not, prompt them again, see if that's valid. All right. No one way is better or worse than another. Okay, you can do whatever feels good to you, and if you're, not panicked for time, play around with it. Try different ways. There's a third way we could do this, which is with a flag. Right? It's kind of a combination of those first two approaches. The flag way would be, set a variable equal to like need and answer. And, well, let's just go ahead and do that. Alright, so I'm setting this flag to 1 to say we need an answer. So I'm going to make my loop say while need an answer is equal to 1, do. And I'm going to change this to an if. So I'm going to prompt the user, I'm going to get an answer, and if the response is equal to a C, or the response is equal to a U, then we don't need an answer. We've got one. All right, very different structure from the other two, but equally good. So I'm setting a flag in the beginning, which says we need an answer from the user. My while loop says as long as we need an answer, let's do all of this. So what do? We ask the person for an answer. If the answer is legal, meaning it's a C or it's a U, then we clear our need answer flag. Right? And then the next time we come up to the top of the loop, we'll say, do we still need an answer? We'll say no, we'll kick out of the loop, and we'll echo the response. All right. These are the things that I'm interested in coding, right? Things like this. This is manageable. If it can fit on one screen of my window, I'm okay writing code. Okay? when it's 50 lines or 100 lines or 250 lines, you don't want to be trying to write an entire 250 line program that does one thing, right? Break it into smaller pieces. So this is kind of a bite-sized piece. It does one very specific function. It's not terribly long. I can implement it a variety of ways, and I can thoroughly test it. Okay? I can run this. I can, put in bad answers. I can put in ha-has and you-yous and so on. And I can convince myself this code works. And once it's done, I don't have to think about it anymore. I'm going to go ahead and I'm going to work on the other parts of my main program. I'm going to write my introduction. I'm going to write something similar to this, which says how many sticks should we play with. Okay? And then I'm going to go ahead and I'm going to start this main body of the loop. And the main body is going to use the notion of whose turn it is to decide, should I ask the user for their move, right? Should I ask the CPU for their move? And this variable that says whose turn it is, maybe I'm just going to alternate that. Right? After the user makes a move, I'll change it to CPU. All right, so I don't know how useful that is. Hopefully that's helpful to get you started if you're feeling kind of brain locked about where to begin with this. Pseudocode is your friend, okay? It's not required that you turn in pseudocode, but certainly if you're stuck and you're looking for help, if you come to me in Zoom and you can show me your pseudocode, it gives us something really good to work on. Okay, it's a great starting point, and it's great for debugging. All right, we're out of time. I will see you in 2:15 if you're in there. Otherwise, I will see you Monday. Have a great weekend. Take care, and thank you.